All right, let's look at the homework 3.11, problem number 3. All right, so let's do a few of these. All right, so let's look at part A. All right, so remember that the definition of a hyperbolic tangent is going to be, so this is going to be equal to, I'm going to go here. So we want to take the limit as x approaches infinity. Right, hyperbolic tangent is a hyperbolic sine, which is e to the x minus e to the negative x over 2. Right, and hyperbolic cosine is e to the x plus e to the negative x over 2. Right. Then first thing is I'm going to multiply top and bottom by 2. So that we can cancel 2 on the bottom here and 2 there, and 2 on the bottom there and 2 there. Right? And another thing is if you plug in infinity, e to the x goes to infinity, e to the x goes to infinity, so the top and bottom goes to infinity. So what I'm going to do is I'm going to actually multiply, or maybe I should say divide by e to the x. So numerator divide by e to the x, denominator divide by x. All right, so this is going to simplify to limit as x approaches infinity. All right, so e to the x divided by e to the x is 1. And e to the negative x divided by e to the x is e to the negative 2x. E to the x divided by x is 1, and e to the negative x divided by e to the x is e to the negative 2x. All right. Then as x approaches infinity, we know that here, this guy, e to the negative infinity approaches 0. Right? And e to the negative infinity approaches 0. So those two guys go away. So you're just going to get the 1 over 1. So this is going to be 1. All right. So let's plug it in to make sure. So this is 1. All right. So let's check the answer. All right. We got part A correctly. All right. So it's very similar, but let's do part C. All right. Part C, hyperbolic sine. So you have limit as x approaches infinity. All right. And a hyperbolic sine, the definition is e to the x minus e to the negative x over 2. Right? In this case, x is going to infinity, so we know that e to the negative x is going to go to 0. But e to the x, e to the really big number is really big, so it's going to go to infinity. So infinity minus 0 over 2 is going to be still infinity. Right? So C is infinity. So let's type it in. We got infinity. All right. So let's check the answer. All right. I came back and looks like we got part C correctly. All right. So let's do part E. All right. So this is hyperbolic secant. So it's going to be a reciprocal of hyperbolic cosine. So you have a limit as x approaches infinity. So hyperbolic cosine is e to the x plus e to the negative x over 2. So we take the reciprocal. So it's a 2 over e to the x plus e to the negative x. Right? Then we know that as x approaches infinity, e to the negative x approaches 0. But e to the x actually approaches infinity. All right? So we have 2 over infinity, which is going to be 0. All right, so let's type it in. We have 0. All right, let's check the answer. All right, I came back and looks like we got part E correctly. So I'm going to skip the rest of them since they're very similar. So all you have to do is using the definition in terms of exponential functions, then just take the limit from there. All right, that's it. I hope that this was clear.